Right. Uh, right. Can you hear me? Can you guys see the screen? Hello.
Okay.
Right. Right. For a like overview, so this is the things we're going to cover, right? So first we're going to cover what is microcontrollers, like then under that we're discussing Arduino, then components of those Arduinos, then the comparison of set of boards. Then we're going to learn the language and to code the Arduino, right? So now we have to like if you we have to do the things in the online manner. So for that, so we are using this Tinkercad, right? So you can create that, you can search on the Google and you can create a account on Tinkercad, right? So the practicals will be mostly based on the Tinkercad, right? So then we're going to discuss in detail manner about how to use set of sensors and like how to power them, like then how to get read from those sensors, like then we're going to discuss about some communication protocols like UART, I2C, SPI, like that. There are some communication part, then the wireless communication like Bluetooth or Wi-Fi. Then we're going to discuss about some IoT aspects, right? So IoT, what are the IoT enabled devices and what is the trend of the in the community now, like in the like commercial products in like what are the commercial solutions for like IoT uh, perspectives, right? So these things are the things we're going to discuss on this physical computing part, right? Then do you have any questions up to now before we move on to the microcontroller part? No, right? Okay, then so just my advice is try to enjoy the uh, these things we discuss in the lectures, right? So you can try out them, right? You can buy your like I'm not going to force you to like encourage you to buy, but right, so you can buy some stuff and try out yourself, right? Then you can enjoy the stuff, right? Don't make it a burden. Okay, so microcontroller. So before moving to the microcontrollers, you know microprocessors, right? So microprocessor is like normal CPU, right? So it has some arithmetic and it can do some arithmetic and logic operations, right? Then it has ALU and CU and some registers, right? So if you get the processor, right, so then we have to provide the other stuff, right? So we have to provide the memory, then some timing things, then the interrupt controllers. We have only in the microprocessor or the processor, we have only the ALU, CU, and the register part, right? So the other stuff we have to provide, right? So watchdogs or whatever the things we have to provide, right? So if you assemble a kind of a PC or something, the PC means like a desktop computer, right? So then you have to put the VGAs, then the RAM, some like if then the like hard drives. You have to provide those things, right? So in the microprocessor, it has only some specific things, right? So but those things are very high end, right? So very expensive, right? It has very good higher clock, right? Obviously, but the other things you have to provide, right? So you know the microprocessor. So in the microcontroller, so it's kind of a, like embedded thing, right? So it has all the stuff it's need, right? So it has the CPU, it has the RAM, it has the registers, then ROM, it has flash memories, then the timers and interrupt controllers, and it has the input output ports as well, right? So it has all the things, it's include all the things, right? So but the thing is it don't have that kind of very high end spec, but it has all the things, right? So So this is the microcontroller, right? So microcontroller will look like this. It has several pins like in the CPU, right? So the different is it has all the things it's necessary, right? So microcontroller means IC. No, IC means like integrated chip, no? Right? So like it's kind of a like a very it's in integrated chip. It has certain functionality, right? So microprocessor is a kind of a integrated chip, but so it has more functionalities than the IC, right? Right. So now you have a microcontroller, right? So if you consider the clocks or the expensiveness, so there is a lot of difference. But the why we need the microcontroller, it has all the things it needs, right? We don't need to provide RAM or whatever, right? If you can just like plug and play something like that, right? So in I'll show you in the next slides, right? So you can even remove this and replace it with another one, right? So with another set of codes, right? Suppose you are writing some code in this chip, right, to like sense the outside temperature and send some SMS to a mobile phone, something like that. You can write on this chip, right? So then again, if you need some another functionality, right? So without erasing the or editing this chip, right? So you can replace it by the another chip, right? So you don't need to. There are no dependencies, right? So you can remove. You can. So all the stuff you need is inside this chip, right? So that's the overview. Okay. So why we need microcontrollers, it's cheap and because it's cost effective, right? So you can get it by in the market. Those things are readily available, right? So if we so the architecture like like an overview, so it will look like this, right? It has the IO ports, then it has the ROMs, then communication ports, then the interrupt controllers, memories, CPU, then timers. You have all the stuff you need, right? So if you go for a CPU, it's expensive, right? Then you have to provide the things it needs to work, right? So if you have only the CPU, right, without memory or RAM, right? So in that case, it can't work, no, right? So you have to provide that memory as well, or the secondary or those memory types, right? So that is the difference, right? So if you consider the some overview architecture, right? So in the microprocessor, you have ALU control units and the registers, right? Then the all the stuff, these things you have to provide, right? You have to put some input devices, output devices, and the memories. You have to provide those things. But if you get the microcontroller, it has the all the peripherals it need, right? So it has the communication interfaces. It has like memories, interrupt controllers, watchdogs, clocks, input output ports, right? You have everything, right? So it will, if you just code it and use it, it work, right? So you don't need to like consider other aspects, like how many memories we going to put here, like how we going to match those bus speeds, those things. You don't need to worry about those things, right? It's just work, right? So because it has the all the peripherals it needs, right? Then if you consider some certain aspects, right? So in the microprocessor we are basically using it, like you know that those things, no? Right? In the microcontroller we are using in kind of embedded devices, like it can be in your smartphone, it can be in your like washing machine, or like what else, then the some small robots, then the drones. So you have those so the those are the two application levels, right? So if you need a microprocessor, like if you need to do some like very expensive like video editing, or like some very something like very complex calculations or whatever, so you need to go for a microprocessor. But if you go for some like very cost effective some small system, if you need to build, so the best option is the microcontroller, right? So obviously the processing power, if we consider, so in microprocessors now we are normal our personal computers, we have kind of a gigahertz level, right? So but in the microcontrollers we have like a megahertz level, right? So that is the difference, right? So but if we consider this megahertz level in this kind of a physical system, right, in a physical computing domain, so that is a very higher clock, right? So that means you can do some 16 multiplied by 10 to the power 6 or something, right? So so it has that kind of clock speed, right? So that means you can, for 1 second you can do that kind of calculations, right? So in if you consider in the this physical computing thing, so that clock is enough, right? So then the memory, if you consider the memory in the microprocessor, it has some kind of a, you can upgrade your memory, say you can throw some two sodiums and then that will work, right? So but in the microcontrollers you have only limited size, right? So when they manufacture in the some kind of a microcontroller, they specify so this much, like 32 kilobytes, so like that much level, right? So but in like if you're doing this stuff, you will realize that that 12 kilobyte or whatever will enough, right? So then the power consumption, obviously microprocessor is a very very higher processing power. Obviously it has a higher power consumption, but in the microcontrollers you have certain like sleeping modes, like then by that you can utilize the power, right? So the power drain will be very low, right? Then most of the time those microcontrollers look small. Then the price, obviously microcontrollers are very cheaper. Then it has the IO pins, as I said before, it has digital and analog input output pins as well, right? So if you consider the microprocessor thing, so you have to uh, add those external peripherals to that microprocessor, right? So this is the some very brief comparison between two, right? So in here we're going to discuss about microcontrollers, and Arduino is one instance of microcontrollers, some like enhancing the microcontroller. So I'll show you that story as well, right? So if you have any questions up to now, you can ask. No questions? Right, so these are some microcontrollers you can find in your day-to-day life, right? So it can be in your car, like you have ECU, right? So there is some controlling stuff, right? Then in the machine or the motorbike, iPod, whatever you name it, there are certain microcontrollers, right? So these things are you can meet in day-to-day life, but so these things hide under the your that gorgeous displays, right? So that's the issue, right? So you can actually find those things in your day-to-day life, right? So that's the end of the first part, right? Then that's it. So are the processors in smartphones are microcontrollers? Not specifically, right? So in the old days, so some in the earlier we have like so in like we have that processors specifically you have processors in smartphones, right? So but like in the older days, right? So you can find there is a, you can have limited number of operations, right? So in that case, so there are certain microcontroller levels, those start from that and come into this processing thing, right? So the thing was like if we like if you go for a microcontroller, that is very you do define that all the spec at when you are uh, like developing a chip, right? So but in the industry they need that flexibility, right? So you throwing some CPU, right? It can be Intel or whatever, right? Then you can have, so that will uh, then you can increase your, suppose you need to increase your memory, right? So if you go for a microcontroller, that it has a fixed size, right? So you have a limitation here, right? But then, so those people divide these things into two parts, right? So in the CPU we only provide ALU, CU and registers and some specific things, right? Then the other things you can change, right? So if you need more memory, you can throw some memory things, right? So yeah, there are nothing on the screen, right? Don't worry, right? Then I'm going to move to the Arduino part, right? So let me know if you guys need to go for the vaccination thing, right? So I let you leave, right? So now we going to discuss some Arduinos, right? So what is this? So the roadmap will look like this. So first we discuss what is the Arduino and why we need the Arduino, then some components in Arduino board, then the comparison, how to program and compile some code, then deep dive into the programming language, right? In today's we're going to discuss up to this point, only the components, right? So then the next lecture we can do the interactive part, right? So what is Arduino? Arduino. So do you guys heard about Arduino? Or microbit or Arduino? Do you have any idea about those things? Are there any people who done programming on Arduino, speak microbit, whatever? Come on, guys, you have to speak up, right? So I'm the one who conducted the lectures. Then you have to speak up, right? So otherwise it will be getting boring, right? So one guy telling no, Tushari has no experience on those things. Then what about others? Come on. So I'll stop around 11:45 if you speak up, right? Otherwise I'm going to do the lecture up to 12. Okay. No one?
Yes, sir.
Yeah.
Sir, I have an idea, sir, but haven't actually programmed in that.
Okay. So you have idea about Arduino or pick whatever what
Yes,
you
sir, like
have
the general
general
ideas, like
idea.
yeah.
Okay, right. Meleka having some kind of experience on Arduino. Okay. Okay. Who's this? Someone telling he's tried to do a line following robot, but it didn't work. Right. Okay. So we'll try to fix this on these lectures, right? So I can't. So Wing. Sorry, I can't read your name correctly. Wing. Sorry, I'm not going to read your name. Right. Okay. Right. So some of you have tried the stuff, right? So some if you have some idea, right? So up to now you know what is physical computing and what is microcontrollers, right? So in this lecture series we're going to do stuff on microcontrollers, right? So obviously if you're using the microprocessor, right, so that will be expensive, right? It's too much for this work, right? So that's why we specifically go for microcontroller. It has certain clock speed, right? That will be enough to work with the analog world, right? So but it will so depend on your problem or the project, right? So the Arduino is so those things are the microcontrollers, right? So we have microcontrollers here, right? It has certain pins. It's look like this, right? Then so the thing is in the before the Arduino was there, right? So the people have to, so we have a microcontroller. So suppose you have this Atmega 328 microcontroller, right? So the old days the issue was, so if you go into like do some very complex project or something, right? So you have to by your hand you have to connect all these peripherals by yourself, right? So you have only this chip, right? So you have chip, you have all the stuff that chip need, right? So it has pins, right? You can connect each pin to whatever the power sources or the that peripherals, right? So you have the chip. But the thing was, so if you're going to connect these displays or these keypads, gas sensors, push buttons by your hand, like uh, by you, right? So that will be a very and time consuming and very headache, right? So it will, that's a kind of a disaster, right? So if you consider nowadays, right? Previously there were no options, right? You have to do it by yourself. And someone Udesh, I think your video is turned on. Okay, right. Then so you guys like chilling out, no? Okay, whatever. Right. So the thing was, you have microcontrollers at the early stages, right? Then so you have to do the connecting part. You have to wire those stuff to microcontroller and give some giving power source, like connect giving powers, like if we, so it will work on 5 volts or whatever. You have to specifically uh, control that voltages and give it to the microcontrollers, otherwise those things will burn, right? So that was the early stories, right? Then what, there is something called Arduino. So Arduino, those people come up with the physical computing platform. They build a platform that is the leading one, and I'm also a fan of Arduinos, right? So there is some kind of a like competition between Arduino and the Microbit. Like Microbit, like it has a long way to come, right? So, but Arduino is some like matured thing, right? It has a very large community support, right? Then so these things are, so these are the boards that uh, connected with the microcontrollers, right? So you have you can find the microcontrollers here, right? So this is the microcontroller. Then in this, yeah, the chip is missing, right? So then so you have the microcontrollers here, right? So the Arduino did was, so they build a board that the anyone, the beginners, can do stuff on using microcontrollers, right? So they give some pins, right? So you can simply plug and play. We can like using some wires, you can plug the stuff into these things, right? Then you can give powers. You can just plug it to a laptop and program it, right? So it has, so by using these ports, you can plug it in. There's a IDE. Using that IDE, you can code the microcontroller. Sorry, Arduino, right? So basically microcontroller, right? So the Arduino did was like it they like removing all those hazard at the early stages and give us the opportunity to try out the microcontrollers in a easy way, right? So it is a kind of a electronic board, right? It don't have any brain. So the brain is the microcontroller. So you can put that brain into this board, then use the pins or whatever in that board, Arduino board, to use it, right? So other than connecting those stuff by yourself, right? So it is like that is the thing. That's why most of the people like Arduinos, right? So in the early stages, so if you're going to use the microcontrollers directly, so you have to think of a lot of things, right? So the power sources, then how we going to connect those stuff, how we going to sync the all the peripherals, those stuff. But by this solution, this Arduino, they give a one solution that anyone can use the Arduinos, right? Anyone can do developing things on microcontrollers, right? So it's hardware products are licensed under these, then software products licensed under GPL, right? So these things are, so that anyone can manufacture these Arduino boards and anyone can redistribute those stuff, right? Arduino boards of the software. So this is a kind of so this is an open source solution, right? So it has large community support and it is our work, right? So that's why we going to study Arduino on this lecture series, right? So if we in the earlier we have something like peak, right? Peak programming, right? So it have some complexity than programming the using Arduinos, right? So if you are if you have some time, you can search what is PIC and how we going to program the PICs, right? In there's a so since you guys didn't come to the university physically, right? So there is a thing called electronic lab or the embedded lab. In that we have all the stuff, these Arduino boards, then the microcontrollers, then PICs, then uh, like I think Dr. Hiran did some introduction on that as well in the in his lectures, right? So so you can come to that place and you have to gain permission, then you can come to that place, then you can work on your project, right? So that's for you people, right? So then so this is the Arduino, the story behind the Arduino, right? So why we going to use Arduino is like, so it is very inexpensive, right? Cost effective, right? So if you search on Google, right? So there are a lot of websites selling Arduino boards in Sri Lanka, right? So like you can see, so you can buy a Arduino Uno. We call this Arduino Uno, right? So you can buy this board some price like this in the, so these things I think now the price is higher, but due to the situation on the country, but earlier it was around 900 rupees, right? So there are a lot of uh, options, a lot of boards, right? So you can buy it, so these things are very cost effective, right? So you can just buy it from your some kind of a shop and you can program it, right? So then so one is the inexpensive on the Arduino boards, then the other one is the that cost are very low in the sensors, right? So these are the set of sensors you can buy, right? So this, so you can see, so this will, so the functionality of this sensor is to like identify whether there is a human being around certain area, right? So the price will look like this, right? Price is under 200 rupees, right? Then in this sensor we basically use for finding obstacles, right? Then measuring the distance for obstacle, right? So it's cost around 300, right? So if you consider the functionality and the accuracy, right? So you can see there is a uh, the price is very low, right? So that's why that's the main thing we're going to move for the Arduinos, right? So then wide range of choices in, even in the Arduino boards there are a lot of boards you can find. Then in the, even in the sensors, like you can pick the correct one that will work for your project, right? So if you need the higher accuracy, then you can, there is certain sensors you can move for that accuracy, but the price will be higher, right? Then if you just need a rough idea, then you can go for a low quality sensors, then you can use those things, right? Then it is so most of the time we are using these Arduino boards to prototype some systems, right? So it kind of like proof of concept stuff, right? So you can like even like spend in 2 3 hours, you can prove that these things will work, right? Then the industrial aspect you can spend like 1 year or something like that, then come up with the commercial product, right? But in the Arduino, that work is, so they got basically developed for prototyping in the systems, right? And this is the UI we going to work, right? We call it Arduino IDE, right? So so if you plug that, if you open, you can download this IDE from by searching it, right? Then you can plug your, there's a cable to plug that Arduino device into the laptop. Then you can simply code it on this Arduino IDE, right? So easy to learn, obviously, and it has a kind of a very higher level of like libraries. There are a lot of libraries, right? So you can use those libraries as well, right? Then large community support, obviously if you search certain thing, there is a lot of people who are supporting, and since this is an open source project, right, so they are supporting and supporting each other, right? So then yeah, open source, so I discussed that. Then we're going to discuss about some components in Arduino board, right? So these are the some these are some Arduino boards, right? So compared to, you have this dollar bill in, you can compare the sizes, right? So you have a ruler here, right? So if you see, so even this kind of a smaller uh, space, right, you can come up with your solution, your project, right? So this will work, right? So if you need to flight some kind of drone or something, then you can go for certain this kind of board, right? So it's smaller, it's less power consumption, like that. These boards have certain like several properties, right? So you have to go through the data sheet. There is a thing called data sheet. In that data sheet, it has all the details, right? So what is the working conditions, like what is the max voltage, max current, then that the what else, like some spec about the your Arduino board, then the like operating conditions, what are the operating conditions we have to meet, like there is a, for every, even for the every sensor, right, there is a data sheet, right? So you can study the data sheet first, then you can pick a correct sensor. Then for the Arduino boards as well, there is a data sheet, you can spec the data sheet and uh, go for a best solution, right? So these are the things in our lab. We have Arduino Unos, Megas, and Arduino Nanos, right? So and Pro Minis, as I'm not sure about that, right? So basically we, so most of the time we are using this Arduino Uno, right? So it's kind of a like a mid-range one, right? So if you consider Arduino Mega, so it has a lot of IO pins that, like it has a lot of capabilities than the Arduino Uno, right? But so but the Arduino Uno is a kind of like mid-range one. That's why we are using that one. It is easier to use than using the Arduino Mega, right? Yeah, someone asking, are these all Arduino board exist? Yeah. Oh, are there? Yeah, there are more boards, right? So these are, so there is a, so these are the not the only boards we have, right? So if you search, there are so many options, right? So this is just a kind of overview, right? So like it has certain range, right? So if you go for a like very uh, space constraints, right? If you have many space constraints, you can go for these kind of small boards, right? So Nano is the favorite one, right? Then if you go for a mid-range one, you can use anything on this area, right? Then if you go for some very large scale or something like that, then you can go for this area, right? So this is just the overview, right? So you can compare the sizes as well for these coin and dollar bills, right? So you can see the sizes, right? Okay, any questions up to now? Then it's almost 11, right? So any questions? Right. So I'm going to discuss the components of a Arduino board, right? So this is just the Arduino Uno, right? So you can see it's telling Uno, right? So in so these things will made in Italy, right? So in our like in our shops we have Chinese ones, right? So the the genuine ones are uh, like developing on Italy, right? So those things will cost around 6,000, 7,000 on those days. I'm not have idea about nowadays, right? So now we're going to discuss the components of Arduino board, right? So for to do that one, we are using Arduino Uno. As I said before, it's kind of a mid-range one, so that will enough, right? So if you see, there is a microcontroller, obviously. So this is the microcontroller. You can even remove it, right? So you can put some stick onto the side, then you can very carefully remove it, right? So don't do that on the lab, right? So there are certain things, certain scenarios you have to go for that solution. But other than that, we don't removing the microcontroller out of the Arduino boards, right? So you have the Arduino board, right? So this microcontroller, these pins, and all these things are mapped to another layer, right? So the layer we can easily use, right? So you have a set of ports here, right? You can use some jumper cables and insert those jumper cables into these things, right? So this Arduino board work is to just to map this microcontroller with the kind of easy to use interfaces, and give some like sync in the stuff and regulating the voltage, those things, right? So, and someone asking, all these boards do make some functionality which you showed in previous slide, or each board perform different functionality. Like, so the functionality means like all the functionalities, it's like, so the functionality depend on the microcontroller, okay, right? Then you can it's like suppose if you need I'll show you example on the previous slide, right? So there are specific things, right? So if you need the SD card, you can go for this kind of a Ethernet one, right? So you can even plug in your Ethernet cable here. Then if you go for a Wi-Fi kind of a solution, then you can go for this kind of a board, right? So that's depend on the your like your need, right? So what is your requirement, right? For that you can add more functionalities, right? Basically you have a microcontroller, then that microcontroller map to certain pins, right? So then if you need more additional things, right, like that, if you need something uh, like if you need to store some data, right? So in a local, then you can go for this kind of a Ethernet solution, right? So that's depend on the your requirement, right? So okay, right. Yeah, shield is like someone asking what is meant by shield, right? So shield is a kind of a thing that we can plug onto these uh, boards, right? So if you need a Wi-Fi shield or Ethernet shield, suppose you are using Uno, right? So it has all the basic uh, uh, functionalities like it's it don't have the SD cards, it don't have a port to connect the Ethernet, right? So in that case, if you need something to go for, like if you need to access the internet, right, to browse the some certain websites or whatever, or store some data, then you can find a shield, right? So there's a thing called shield. So in that shield, it has only like Ethernet shield, it has a Ethernet port, it has a SD cards, then you can plug this into these pins, right? So top of this Arduino Uno, right? Then it will again map these pins to another layer, right? So these pins are not wasting. So Ethernet shield only requiring certain number of pins. So he will get certain number of pins. Then the rest of the pins we can use from top of that shield, right? So yeah, we can put certain shields top of each other, right? We can connect set of shields, right? Right. Normally we using some basic go for a basic Arduino board. Then if you need certain functionality, like if you need Wi-Fi or Ethernet, or a GSM modules, like if you need to like track the GPS location, so if you need to send SMS messages, so for those things you can uh, use a GSM shields, right? Then like that we are come up with the very basic Arduino board. Then we stack up the certain the shields we need, right? So that's how we going to do the stuff, right? Okay, Then yeah, we were at this point. We have Arduino. So we have Arduino Uno. We have microcontroller here, right? Then we have crystal oscillator. We call it as crystal oscillator. You can find this kind of a thing on your motherboard as well in your personal computer, right? So then we have digital pins. We call these digital pins. So we have 0 to 13, 0, 1, 2, 3, like that. So we call it digital pins. Then we have analog pins started from A0, A1 to A5, right? So we have 6 analog pins here, right? So then we have ground pins, set of ground pins in the analog side as well as in the digital side. Okay. Then we have certain pins. If you need to power up LED, or if you need to drive kind of a motor, something like that, you can take the power from these these pins, right? We have 3.3 voltages and 5 voltages, right? Then we have analog reference pin, right? So to refer a certain voltage level, right? So normally these Arduino Uno work to like you can get about 40 milliampere current. Then it will work around 0 it has the scale around 0 to 5 voltages, right? So you can sense anything within 0 to 5, right? So then we have ICSP pins here, right? So we call it ICSP pins. It's kind of using for communication purposes, right? Then we have V-in pin here. So for that, we are using that pin to power up the uh, Arduino, right? So you can give, sorry, you can give power from that pin and ground the stuff, then that will work. Then if you're not going to use that pin, so the normal behavior is you plug it to the USB of your laptop, right? So there's a cable, right? You can plug it into this port, then you can plug the other into the laptop, then you can program the Arduino board, right? So once you program it, so that program is always there, right? So in the early days, so if you losing the power, in that case, so the code also getting erased, right? But in here you have that functionality. You can store that program on your Arduino board, right? Then sorry, in the microcontroller. Then you have the power jack, right? So we are using this USB plug to program most of the time. Then after you program it, you if you need only to power up the Arduino board, you can put this there's a jack, then you can put it here, right? Then you have a reset button, right? You can press that button and restart the program, right? So I'll show you the I'll discuss these things detail, right? So then we have the voltage regulator here, right? So this thing will regulate the voltage that goes to the uh, Tushari. What is memory chip means? What do you mean by memory chip? You mean RAM or something like that? Yeah. So as I said before, right? So all the memories and registers, all the things are in this microcontroller, right? So you can't span the memories or whatever, right? So this microcontroller has the all those specific memory type, memory sizes, then the set of defined IO ports. Those things are in that your microcontroller, right? So for the Arduino, we are basically using to interface that same microcontroller into kind of this kind of a very easy to use manner, right? So it just providing the interfaces, right? It can't increase or decrease the memory, so those stuff. Okay. Then what else we have? Yeah, we have the USB controller. That USB controller is the that controlling and that controlling the that communications, right, between your laptop and the owner board, right? Yeah. Then So then we have certain LEDs, right? So as you can see, this is one LED here. Then we have another two LEDs here. Then another LED here, right? So this LED will turn on when you giving power to your Arduino board. Then we have thing called RX and TX, right? So if there is a UART communication from Arduino board to laptop or laptop to Arduino board or whatever any other sensors, these LEDs will blinking, right? Then there is another LED that will attach to certain pin we call that pin number 13, right? So if you give some current to this pin number 13, this LED will power turned on, right? Right. So those are the very basic things in the Arduino board. Yeah. What is the crystal oscillator, right? So before that, so I'm going to discuss these things in a detailed manner, right? Don't worry, right? So the first thing is the microcontroller, right? So these are the microcontrollers, right? So it has different sizes and different capacities. Like some microcontrollers have higher memory, then some has higher computation power, like that. It has certain specific things, right? So then so you can see that microcontroller in your Arduino board. So this is the Arduino board, and this is the microcontroller, right? So it is the brain of the Arduino board, right? So Arduino board can't do anything, right? So all the stuff work on this inside this microcontroller, right? So the it's come up with like a pre-programmed bootloader. It has a bootloader, right? So if you have that bootloader, then you can simply plug this microcontroller into your Arduino board. Then you can plug the Arduino board into your laptop. Then you can easily program the microcontroller, right? So the you have to give that idea, get that idea, like, so this Arduino is one only giving the interfaces, right? So it only make our life easier, right? So it can't enhance, like enhance the like usage, right? But it can't enhance the some certain specific it if you need to increase the memory, right, inside this microcontroller, you can't do that, right? If you need to increase the processing power or something, you can't do that. It has a defined thing, right? So only the Arduino boards only provide the certain interface that will easy to use. We can easily use that microcontroller, right?
Excuse me, sir.
Yeah.
So, like, if we are using only a microcontroller, like without the Arduino board,
Mm-hmm.
then how do we put our program into the microcontroller?
Yeah, by connecting these pins, right? So there are certain set of pins, no, here. Yeah, you can find there is a set of pins, right? So you have to put it in kind of uh, some like that female part of the this micro this microcontroller. You have certain thing like this, right? So it has certain uh, pin outs, right? Then you can plug this into this thing, right? So then you have that mapping. So this each pin is mapped to another layer, right? So you can actually do that one. So that will be a very complex thing, right? So the thing is, so by using this Arduino, it's give opportunity to work on your project rather than this mapping this stuff, right? So when you even programming this kind of a microcontroller, you have to there is a certain method, right? So you have to specify certain voltage, then you have to change this mode, the mode of the microcontroller into programming mode. Then you can uh, send your code, right, from your laptop to this microcontroller, right? So there is a lot of work to do, right? So that will basically wasting your time, no, right? So you are just like you are just building the environment, right? So that will cost about 2 3 days, right? So that's basically uh, affecting your project, right? So by using Arduino, you can simply using this interface, right? So then you can mainly focus on your project rather than this mapping stuff, right? So there are certain modes in microcontroller, right? So you have to go for certain on like go for the certain uh, modes like programming mode. So you put in the chip into programming mode, then you transfer in the program code, right? So in in your, if you use in the Arduino IDE, it has kind of a C or C++ language, right? So then it will turn it to bytecode. Then you are transferring that bytecode into microcontroller like that, right? So there is a lot of work to do. Okay. So
Okay, sir.
if
Thank you.
you can actually Google it, there are certain people who are doing this stuff on directly, right? So then someone asking, are there any shields to increase memory or any solutions to improve memory? I'm not sure about the memory, but you can come up with kind of a SD card or something. Then you can store the stuff, right? So, but I don't, I didn't find anything like that to increase the working memory, right? Your primary memory. So I didn't find anything like that up to now, right? So I think that those things will depend on the microcontroller, right? So if you can increase the main memory or something, that basically like out of the scope of the microcontroller, right? So yeah, go ahead. Someone raising hand. Okay, I think.
Sorry, sir, it was a mistake.
Okay, sure. Right. Then right, so now we have the microcontrollers, right? So so the Arduino basically give you a chance to directly upload your program code to this microcontroller, right? So the same thing as I said before, right? So it has certain flash memories, RAM. Yeah, someone asking microcontrollers often, yeah, he telling that those microcontrollers will burn most of the time. So I think the reason was about the voltage controlling or something like that, right? So if you're using directly using the microcontrollers, so are you directly using the microcontrollers or are you using microcontrollers inside of Arduino? Inside Arduino. If you are burning the stuff, then so I didn't burn a lot of boards up to now, right? So it has about uh, 4 5 years, but I rarely burn the stuff, right? So if you are burning the Arduino boards, that will be you need to looking for kind of a voltage thing. I think the power sources, right? So so most of the time that Arduino Nano boards, that is very small, right? That is very most of the time it will burn, right? But if you consider Arduino Uno boards or Arduino Mega, so those things rarely burning, right? So I think for your question, I think the issue with your voltage or the current, those stuff, right? Also, if you try to run a motor or something from your Arduino board, so that will be a disaster, right? So as I said before, see these Arduino board has certain limitations, right? So you can't take around 1 ampere or something out of these pins, right? You can only gain around 40 milliampere, right? Milliamperes, right? 40 milliamperes, that is the max current you can input and like output, like if you can, if you need to reading kind of a current 1 ampere, you can't do that, right? So for that you have to come up with another solution, right? So we'll discuss those things in this lecture series, right? So it can be either in the power sources in this area, or it will be on when you are draining the current out of the Arduino board or inputting the current to the Arduino board, right? So you have to keep in mind your limitation is 40 milliampere, right? Most of the time. And you have the working voltages will be like up to 1209. I can't actually remember the exact number, right? So you have that voltage and current limitations, right? So you have to work on those limitations, right? Okay, now you have kind of idea about microcontroller, and these are the some microcontrollers. We call it Atmega 328P, then Atmega 2560. Like that, you have several microcontrollers, right? So this thing on Arduino Uno, this one on Arduino Mega, I think. Then Atmega 168, I think Arduino Nano, right? So and Atmega 328 also in the Arduino Nano, as I remember, right? So this is about the microcontroller. Then the crystal oscillator. Someone asked about the crystal oscillator. So crystal oscillator, you can find it as like this in the your Arduino board, right? So it kind of a pendulum, right? So it has kind of a, so you know the pendulum, no, that butta thing, right? So that will, so the feature of the butta is, so it has a, so if it is configured for 1 second, it will ticking for 1 second, right? So it basically keeping the uh, time. Yeah, it's keeping the time, like tracking the time, right? So if you take out the crystal oscillator, right? So oscillator means, you know, the oscillating this stuff, no? Crystal means this thing built with the crystals, right? So this is the crystal oscillator. It has kind of a number here, 16, kind of something like that, right? So the basic need for a oscillator is like, so it basically syncing this stuff, synchronizing the all the peripherals and the microcontrol, right? So it generates certain number of ticks, right? So for a 1 second, it can oscillate around 12 or 16 million times. That means if you consider 16 or 12 megahertz, right? So that basically generating the ticks, right? So I'll show you how it works, right? So for each tick, so that the oscillator generating ticks, no, right? So this oscillator generating ticks, right? So if you uh, look the uh, that what you call that wave of this tick, right? So that will be look like this, right? So for a 1 second, it will make it. So we call it in normally in Arduino, we calling 0 as low. We call it low voltage. Then for 1, it's high voltage, right? Okay, keep in mind, right? Then if you consider the voltage levels, it is 0 voltage. This is V. Then for 1, it's almost 5 voltage, right? There are certain things. I'll discuss those things later, right? So what will happen if it is 4.9, whether it's 1 or 0? So basically 1, right? So if we consider 1, that means almost that the value will be 5 voltage. If it is 0, that means the voltage is 0, right? Then in the crystal oscillator, it's creating these kind of a pulses, right? So I'll try to do it better. We'll see, right? Something like that, right? Then so in this uh, in here, right? So we call it this is as uh, rising edge, and this is as falling edge, right? So you have only these two, right? So we call it, this is high voltage and this is low voltage. And in this wave, we call this is as a rising edge because it's rising from 0 or low voltage to high voltage, right? It's rising, it's increasing, right? So this is the rising edge. And this is the falling edge. It's coming down from high voltage or 5 voltage to 0 voltage or low voltage, right? So yeah, so this is the clock cycles. I'm coming to that point, right? So in this so now we creating this wave, right? Now there is a microcontroller. So we telling that microcontroller to do certain work at each time, right? So it can be either on rising edge or it can be on falling edge, right? So we telling the microcontroller to, if you are seeing a rising edge, suppose now this microcontroller work for rising edge, right? So if you are seeing a rising edge, you should do some work, right? So it can be addition or subtraction or whatever, right? So each tick, So each tick means it can be the rising edge, it can be the falling edge, right? So you're instructing your microcontroller, or you are synchronizing the microcontroller and the other peripherals as well to do certain work. Then suppose right. So if you are seeing this now, now if you are seeing this rising edge, now I'm telling to microcontroller to add certain add two numbers or whatever, right? So it doing some operation, right? Then again until seeing another rising edge, right? So if we are seeing another rising edge, then it instructing, it's telling the microcontroller, okay, now stop doing that work, do this work, right? Doing Stop doing the adding part or whatever. Now do this one, the subtraction, whatever. So that's the kind of a high level thing on the adding and subtraction. But the thing is, it basically synchronizing and instructing the microcontroller, right? So if this is 16 megahertz, right? That means for a 1 second, it can work on 16 million times, right? 16 million times. If you think that is a very large number, right? So that is well enough in this physical computing domain, right? So it basically instructing to do certain work, right? So that is the thing with the crystal oscillator, right? So it basically calculating the time, right? Keeping the time, right? So someone can ask whether why we go for a crystal oscillator, we can go for kind of a real, like kind of a clock or something. The thing is, so this crystal oscillators made out of crystals, right? It has a very precision, right? It has a good accuracy on calculating the time, right? Keeping the time. That's why we are using this kind of a crystal oscillators, right? In here also there are certain manufacturing levels like high-end things and higher clock rates, right? So normally, yeah, using this crystal oscillator for keeping the high accuracy on the timings, right? So that is the purpose of the crystal oscillator, right? So yeah, it's basically synchronizing all the peripherals and the microcontroller, right? So if you are seeing this kind of a number in a microcontroller, that basically means it has 16 megahertz, right? Or 16 million hertz. For a 1 second, it can oscillate 16 million times, right? That is a very large number, right? So that means like, uh, so it's up to your imagination, right? So, okay. Then these are some type of oscillators, right? So these are type of oscillators for different works, right? So someone can ask whether we can increase this now the timing. So all the timing is done by the crystal oscillator, no? So for then someone can ask whether if we increase this 16 to some kind of 28 megahertz or something, whether it's increasing the clock of the microcontroller, right? So nobody that asked, so that then I'm going to tell the answer. So the thing is you can't, right? Because so the other peripherals, then the other bus speeds and the working conditions on the microcontroller, those things are fixed size, right? So if you can uh, increase a little bit, right? But even in the CPU you can overclock it, no, right? So like that you can increase the uh, like if it is 16, you can go for like 18 or something like that, but it will drain more power and it will generate more heat, right? So these things are designed for a certain specific specification, right? So if you try to like this is kind of a overclocking thing, right? So if you're familiar with overclocking, then so this is kind of a overclocking. Okay, you are basically increasing the timing on the one end, right? So then the microcontroller adapt to that clock speed, right? So okay, any questions up to now? No. Okay, then yeah, I'm going to discuss the type of pins we have in we basically we have digital pins, right? So these things are the digital pins, right? So it started from 0 to 13, right? Then so basically out of these digital pins we can get only digital values, right? That means 0 or 1, right? No middle values, right? So this Arduino is coming from a digital domain, right? So that basically means you cannot have analog values, right? Analog means the continuous one, right? So it can be 0, 0 0.001, whatever, right? So you cannot have that things on Arduino because this thing made out of digital peripherals, right? So this is a digital word, right? So because of that, right, most of the time you have this kind of digital values 0 to 0 or 1, right? But you can like tweak it to that we call PWM, right? So I'll discuss that in the next lecture, right? So you can like, so suppose this one, right? So you are creating a you're going to power up LED, right? So this is the LED. Then you are giving some uh, giving 5 voltage and light up the LED, right? So suppose then if you need to reduce the intensity, right? So if you give 5 voltage, it has certain intensity level, right? Suppose 100 or whatever, right? Then the other value is only the 0, right? So as I said, you can either send 0 value or a 5 value, right? So if you send 0 value, then the LED won't be power on, right? So that basically turn on the LED, right? So if you need to reduce the intensities, right? That means if you need to get some middle values rather than 0 and 5, right? You can do that, right? But if you check the values out coming out of these pins, that is 0 or 5 voltage, right? But the analog world like LED or motor or whatever, those that analog world seeing it is as a kind of a middle value, right? So now you are uh, giving output of value either 0 or 5, right? So if you try to like, I'll do the theoretical part of the next lecture, right? So I'm just need to give you some idea, right? So then if you need to give some middle values like 3 voltage or something, right? So out of this digital Arduino, you cannot give output like 3 voltage, but you can give some kind of a 3 voltage by using this 0 and 5, right? So if you check the out voltage from these pins, that is we have only 0 and 5, right? Because it is digital world, right? We have it has a binary, right? 0 or 1. But that if we do certain work, right, you can sense that kind of a middle value, kind of a 3 voltage to analog devices, right? So that the theories we call it as PWM, right? So in here you can find, right, if you see there is some small dashes like this inside in front of certain value pins, right? So we call it as digital PWMs, right? So you can actually rather than getting out of 0 and 5 voltage, you can give middle values, right? But it is only sensing it is only thing that sensing from the analog world, right? So in the digital domain it coming as 0 and 5, but it is it will sense to an analog world as some kind of a middle value, right? That's the story, right? 3 voltage or whatever, right? So back to this slide, we have digital pins. IO means input and output. You can either use digital pins as input, like you can insert certain voltages, or you can take it out certain voltages, right? We can work as digital input and outputs. Then we have on these digital pins, you have some pins that working as PWMs, right? That means that pins that give certain kind of middle values, right? Middle voltages, right? So this dash is the, so if you see this, there is certain dash out in 9, 10, 11 pins, right? So these things we can use those things for kind of a regulating the voltages, right? Then we have analog pins. So as I said before, we can only write the analog values, right? Sorry, digital values, right? So in that sense, you cannot uh, take you cannot output analog values, right? Because of that, these analog pins started from A0 to A5, these things only work as inputs, right? You cannot give output out of these analog pins, right? So if you need to give certain analog output, so you have to use these PWM pins 9, 10, 11 in this Arduino board, right? So if you are considering another like Arduino Mega or something, it has more PWM pins, right? In the mapping also differ, right? So now you have digital pins, then the analog pins. Digital pins you can use either for input and output, as well as kind of a analog output, right? For you can use it for three purposes, right? If you're using for analog output, so the pins should be 9, 10, 11 on Arduino Uno, right? Then if you considering the analog inputs, for that you can use these analog pins, right? So in these analog pins, it has a thing called analog to digital converters, right? So the analog value, some uh, uh, coming from analog domain, it's converted into a digital one, right? So if it is kind of 3 voltage or something like that, so it will represent it as some kind of a 900 or something like value, right? So if we have 5 voltage, if you give 5 voltage, it will represent in the Arduino board as 124, right? Because of, so I'll do the analog to digital conversion ADC. So because of there are only limited number of pins, right? Bit patterns, right? So it has certain number of bit bits to convert this analog value to digital domain, right? So that's why, so in analog pins, if you take a reading or input that going from 0 to 1023, right? That means that mapping vary from 0 to 5 voltages, right? I'll do those things, discuss those things in detail in the next lecture, right? Then we have ARF pins. ARF, one ARF pin here, right? ARF pin means analog reference uh, pin, right? So normally you can work on 0 to 5 voltages, no, right? But if you need to reference certain voltage like 3 voltage or something, right? As I said before, so if you take the norm without considering the analog reference, it will mapping 0 to 5 voltage, that range to 0 to 1023, right? By using this reference pin, analog reference pin, you can map this 1023 these values to certain kind of a middle values, like in between values like 3 voltage, right? So you can define the upper limit, like, so the now the up, if you're using this ARF pin and giving kind of a 3 voltage to that pin, right? It's cutting out the upper limit of default upper limit of the Arduino board as 5 volt. It's taking that the given 3 voltage as the upper limit, right? That basically need for certain scenarios, right? So so these things are the set of pins we have. Then the ground pins basically, if you are consider a current, it's uh, going from minus to plus, so plus to minus, no, right? So you have to have two ends, right? So one is kind of a source, then one is the kind of a grounding stuff, right? So these ground represent as GND, right? These ground pins basically used to ground the circuit, right? So if you are like powering up LED, right, you can put that connect one end to 5 volt, then the other end to ground, right? So So the 5 volt will burn the LED. In that case, you can give some 3 voltage or whatever from this PWM pin and ground it to using this ground pin, right? So these things are the pins we have. Then we have this 5.5 voltages and 3 voltages. You can simply uh, take it out some certain voltage, right? So the current limit is, if you are considering only the voltage now, so the current limit should be kind of a 40 milliampere, right? So you have to regulate the current, right? So those things are the certain pins. Then we have the powering up mechanisms, right? You can either put kind of a jack into this place and give directly the power source. So you can use this USB port, right? You can, by using this USB port, you can either program the Arduino board or you can power up the Arduino board, right? Then you can use this V-in pin as well, right? So the V-in pin is here, right? You can give some kind of a 5 voltage or something and ground the uh, this Arduino board, then it will power up, right? So if it is increased, that voltage will regulate by the voltage regulator, right? Right. So this is the mapping of the Arduino board, right? This kind of a confusing one. So I put this to tell you that, so the even the one pin can act as a different uh, it has different functionalities actually, right? So if we consider this pin 0, so it's kind of if you see the key here, right? So you can see it is kind of coming from black means there is a physical pin. Then kind of this kind of this color, that means it is a port pin. Then this blue color, that means it is a serial pin, right? So then again we have kind of a white one, that basically means it's a integer pin, right? Like that digital pin, right? Like that, for even one pin can act as a several type, it can give certain several functionalities, right? So that is the theory I want to give you, that the point, right? So for even like, if you consider this any pin, right? So it has certain functionality. It can at some point it can act as an input, it another at another point it can act as output, then it can use it as a serial communication, right? Then again it can give some PWM, like as I said before, like values, like that. It has certain functionalities, right? So all these functionalities are like embedded into one pin, right? So you have to have that idea. But so in here, also in the analog pins as well, it has that property, right? So one thing can act as a several kind of other things, like it has certain functionalities, right? Then we have the ICSP pins. We use it for like there's a thing called SPI. SPI means serial peripheral interface. It's a kind of a communication mechanism, right? So you can use this ICSP pin for serial communications, right? So these are the pins we have in Arduino Uno, right? Then we have USB interface chip. I discussed that thing earlier, right? So this is the USB interface chip that basically translating signals from your laptop to uh, Arduino board, right? It's like a translator. Okay. Then we have the voltage regulator that is here, right? So this is the voltage regulator that's regulating the voltages that defined for the that Arduino board, right? So if we have a higher current, or sorry, higher voltage in that case, so that will regulate by the voltage regulator, right? So if you put this into a kind of a higher voltage, so that basically burning up the voltage regulator, but it's saving the all the other peripherals, right? That's the functionality of the voltage regulator. Then we have reset button. So you can physically click that button, right? So this is the it's a physical button. If you press it, right, normally in the Arduino, if you give a power to an Arduino board, if it is has a program that will start to work automatically, right? So it will work like the clock of 16 megahertz, right? 16 million times, right? So it will execute all the instruction based on that clock, right? So if you press this button, sorry, if you press this button, it will stop the program for a few seconds, then restart the program, right? So in somehow in certain things there may be some issues, like when you are running the stuff like for like a few months or something like that, there may be some issues, right? In that case we have to restart the program, right? So for that we can use this reset button. Okay, then we have set of LEDs, as I said before, RxTX LEDs, that basically blinking when it is receiving, Rx for receiving, right? TX for transmitting. If you are receiving data, Rx LED will blink. Then if it is transmitting data, it will blink in the TX LED, right? Then we have the power LED that will show that the that Arduino board is power up now, right? So if you give the power source, the power LED will turn on, right? Then we have another pin LED called pin 13 LED, right? So that's tied up to the digital pin 13, right? So if you give certain voltage, if you give 5 voltage to this digital pin, in that case, though this pin 13 LED will blink, right? So it's just for most of the time we are using that pin, that LED to check whether that Arduino board is working fine, right? So there, if you go to the Arduino IDE, there are some who is the one who's okay, someone is drawing on my right. Okay, so so the story up to now, we have several themes, right? We have set of digital pins, we have ground pins, we have voltage pins, then we have these digital pins. Like that, we have certain pins and reset button, right? So we going to, in the coming lectures, we going to use this pin and connect several peripherals to this Arduino board, right? So then, so with that we can conclude the lecture. So there is assignment, right? So the assignment is a very easy one, right? So you have to come up with the home automation thing, right? So in this home automation you have to have these features, right? So it should be accessing doors, then maintaining temperatures inside the home, then the security measures, then if we have certain like unauthorized access to our home or something, right? So you have to consider those things as well. Then remote monitoring, like using a mobile phone or whatever, like you can have that ability to monitor the what is happening on the your home, right? Then you have to consider about the emergency measures and utilizing the power, right? So these are the features you have to think about, right? Then so the assignment is look like this, right? So you have to specify the what are the inputs you need to consider to give certain feature, right? So if you consider this accessing doors, right? So there is a door, then you can think about what are the mechanisms, what are the inputs you can think about. It can be your fingerprint, right? Or it can be kind of a RFID tags, or it can be using a mobile phone, right? Like that, you have to think about the certain inputs. Then you have to think about the what are the actions or the outputs, right? If you give your fingerprint, so that will basically open your door, right? Then if you're using this RFID tag, that also basically opening your door, right? So you can specify whether I'm going to log these details on another server or whatever, right? So I just need the like very high level thing, right? Not the low level sensors or whatever. Right? So so the assignment, I make the link available until Sunday 11:55, right? Midnight, then you can write the stuff. So I just need the high level thing. So you just have to specify the inputs, right? So I did one for you, this access indoors, right? So you can specify either I'm using fingerprint of a person, or I'm using RFID cards, or I'm using a mobile phone, or whatever. You have to specify the inputs, then you have to specify the outputs, right? So it's a very easy one, right? So is it clear?
ටෙබල් එකක් ගහලා ඇවුවොත් තරණය
Oh,
එතකොට
අවුලන්න. And limited to one page, right? So I don't need very details things. I just need the thing up to the point, right? So specify your inputs, then the outputs, right? So you can specify what you don't need to specify the sensors, those things, right? You don't need to go into that level. Just give some high level idea. Okay. I hope is it clear. If it is not clear, you can ask. And if you have any questions, also you can ask now. It's almost 12, right? Any questions? Yeah, someone telling that I'm not sure if it is too much to ask. Is it possible to show us how to use a data sheet of a specific board? Later, yeah, I'll show you how to use a data sheet. So that will be okay, right? Right. So not for the board, right? For even for some sensor, right? So you have to read the data sheet, right? So you had the by reading the data sheet, then you can have the idea about so what is the working conditions, then what are the things we need to do, like all the spec is in the data sheet, right? So even in the lecture I'll ask to do in the practical. Okay, so in the next week I think whether I don't clear I don't have clear idea about whether we have the we conducting the lectures, but anyhow, so the next lecture will be conducting by Dr. Hiran. Okay, so